Okay, so again, this is the presentation for 4810. Our project is the autonomous lawnmower. My name is Talon, and my group partner is Andy Liu. Our professor is Dr. Yin. So for the itinerary, we'll first go over what is an automatic lawnmower, and then onto the team's divisions and responsibilities, then more onto the specification and the goals of our particular sub-team. More on that later. And then we'll talk about the team's overall current progress. And then we'll discuss what we plan to do over the winter break and this upcoming spring semester. So first, what is an autonomous lawnmower? The basic idea is just to have this robot that is capable of cutting grass without basic human interactions. This robot should be able to use the sensors, things like the main camera, the ultrasonic and LiDAR, to detect like objects surrounding the lawnmower and decide where it should go. And we'll also have a machine learning model to detect whether something is grass or non-grass things. And along that, it'll also try to map the perimeters of the lawn and then navigate the lawn using that very map. So yeah. And our teams is divided into 3 sub-teams. The first sub-team is the chassis, which is in charge of the sketch and the design foundation model of the lawnmower. So this team will be in charge of most of like the CAD design, right? The things that's going to support are the hardware and the computer. And then the second team is the sensor. They will be in charge of the control commands between the hardware and the software. They will create that communication bridge, and they also manage the motors and the sensors. And then the third team, this is Andy and I's sub-team, machine learning. We'll try to apply the object detection and then hopefully also the path planning algorithm using computer visions and the camera that's attached to our machine, our lawnmower. And at the moment, this is our Gantt chart. So we have finished up with most of the setup already. Things like scheduling, which is the Gantt chart, right? Purchase of the parts and the abstracts, planning and the requirements, things like that. And at the moment, we're in the middle of the research phase, and we're still working on it. Each of us sub-team is trying to research on what is the best approach to our individual task. And yeah, this is our timeline, and we hope to finish by March, just in time before the I believe this is the presentation, the research symposium. Yeah, so our professor want us to finish our SDP by the research symposium date, and at the moment our project is about 30% done, so I think we're on good track to be able to finish on time. And then the second is the project requirement. So our professor thought that this was definitely one of the most necessary component to our project, and so we had to come up with like 10 basic requirements that our lawnmower should be able to have. So things like the lawnmower should be able to move forward, move backward, turn different directions, stop, and then give signals like whether it's in operations or not. And like the lawnmower should be able to move and mow on different type of lawns, things like that, right? And then this is our our overall designs of the project. And before I explain, so the few numbers that you see here, like 4, 5, 6, 9, and 10, that is a reference to these requirements here, like which I guess which part that is going to fulfill that requirement. So for the camera, it's going to recognize like when to cut grass or not, or like use computer vision for object detection and classifications, right? So our central processing unit is going to be the Raspberry Pi, and that is connected to the FPGA, the main camera, and the microcontroller. So first we'll gather data, gather and then process the data from the GPS, the ultrasonic, accelerometer, things like that, into the FPGA, and the FPGA will move that data into the Raspberry Pi. And our machine learning team will also simultaneously trying to record images or record images of that are in front of the lawnmower, and then process those images and give that to the microprocessor, and then the microprocessor will try to analyze what is going on so that it can communicate with the microcontroller, which will be the Arduino, and the Arduino will be in charge of like moving the actual lawnmower with these four the four wheels, and then also the blade motor, which will be used to cut the grass. And then our budget sheets. Our expected budget sheet at the moment is $160, and if we ever need something in the future, we have it listed here already. And yeah, so that's pretty much it. And our specification goals, this was meant to be a joke for when we presented in class, but since we couldn't, but overall my goal, my idea of the machine learning team is just to simply like detect grass. That's it, right? So specifically, I'm hoping to create this kind of feedback loop where we, if we see grass, we would approach it and continuously scout for it. And as we do that, we also gather the travel distance from the sensor team, which is things like the GPS coordinations. And using that distance, ideally we also try to create like the 2D model of the field for future path planning optimizations, so that with each use of the lawnmower on the same lawn, hopefully it should be able to understand exactly where it should go, right? And then what it should do without ever stopping to think or analyze its surrounding. And the third one is to detect boundaries based on image localizations. So referencing the images on the left right here, first, our computer vision, of course, is going to be able to do the classification part, right? In this one is detect that it's a cat. In our project, is going to be able to detect whether there is grass inside this image. But then the localization is also extremely important because it put this kind of boundary that tells us exactly where the cat is on the image, or where the grass is going to be on our image in our field of vision. And my idea is just that, like, if say we lose the localization box, right? Like if this little box becomes too small, then we can safely assume that we have reached an edge and that the grass is no longer detected. So we'll try to detect the next course of actions, like maybe do a spin so that we can scan surrounding area to determine our next course of actions. And yeah, and as it do that, if it detects grass again, then of course it's going to approach that grass and then again gather the travel distance. So yeah. And our next step is just to research and practice, basically. Research is we're trying to learn more about like machine learning, like on a deeper level, like how does computer vision work, how does neural network works, which activation layer we should use, or what kind of model we should use, like deep learning, for example. I think that's what we're trying to pursue right now. And then we also try to cross-reference other open source projects that might be similar to ours, and then determine the best approach that we could use on our device for our projects. And then which tools to use. So definitely like TensorFlow to classify images with all those different tensors. And Ubuntu, definitely like the Linux environment is going to better fit for what we're trying to do. And then over the winter, we'll practice with everything that we have researched so far. So I'm going to try to gather like training data and test model, create a data pipeline, and then see what we can do with what we have, and then go out in real life and take pictures of real images, and then try to see if it works, right? And once we train that model, we can try to integrate with hardware, the camera and the Raspberry Pi, put everything together so that it's no longer attached to the laptop, and then we can just set down the lawnmower and let it go. And I guess lastly is to freeze and deploy model. Of course, like the Raspberry Pi, it doesn't have enough processing power, so training data on it is just not going to be plausible. So my idea is just to train it on a laptop or on a computer, and then freeze the model and then just load that onto the Raspberry Pi, so that we can minimize as much calculations done on the Pi as possible. Because as mentioned earlier, the Pi also have to take in a lot of inputs from the the sensor team, like things like GPS, ultrasonic sensors, things like that. So the least power we can use to achieve what we want, the better. And that's about it. Thank you.